Forgive the little bit of glare, but hopefully you'll be able to see the problem as we go through. Okay, here's another type where we are going to use both identities and another method where you have to square both sides. Okay, when I look at this, immediately I think about our trig identity that converts sine into cosine. However, a few of you made this mistake on the test. You cannot use those Pythagorean identities unless the cosine is squared and the sine is squared. Okay, so you cannot use that identity if the function is not squared. So what we can do in this instance is go ahead and square both sides of this equation. Now, here's the one caution, and this note is in Canvas, so you can read over it if you're not understanding what I'm saying verbally. But sometimes when you square things, think about it. If this answer was negative and I square it, I've now changed that into a positive answer. So it's still the right answer, but it's positive. So what we're going to have to do at the end is check for those beautiful, lovely extraneous solutions like we did when we had absolute value equations. So we will worry about that at the end, but I just wanted to make that note now to let you know this is okay. It's the same thing as just multiplying by itself, doubling it, things like that, multiplying both sides by 2. As long as you do it to both sides, it doesn't change the makeup of the function. However, we will have to go back and check for extraneous solutions. Okay, so we are going to go ahead and show how that distributes out. This one just becomes sine squared x, easy enough. But this one you have to multiply through, so cosine x plus cosine squared x, forgive me, plus cosine x is gonna give us plus 2 cosine x. 1 times 1 is plus 1 is equal to sine squared x. So now I see a function where I can solve this, but I have a sine squared on the other side. So think about your identities. What identity do you have where sine squared can turn into cosine squared? And if you remember, cosine squared plus sine squared equals 1. So 1 minus cosine squared equals sine squared. So we can change this to 1 minus cosine squared x, which is all equal to all of this stuff. So now that we have this set up, now we can go ahead and solve getting everything to one side because we have a quadratic equation. So bring everything to one side. So plus cosine squared minus 1 plus cosine squared minus 1. So we're doing the same thing to both sides, right? So now cosine squared plus cosine squared yields 2 cosine squared x plus 2 cosine x. Well, 1 minus 1, those cancel out to 0. So we have no constant that we're adding there, and all that is equal to 0. So now that you look at this, how can I solve this? Well, I notice that there is a greatest common factor between both terms, and it is both that 2 and a cosine. So if I factor out a 2 cosine of x, I'm left with a cosine x plus 1. Right? Because if I divide each term by 2 cosine x, left with a cosine x, divide by 2 cosine x, all I'm left with is 1 here, because 2 cosine x divided by itself is just 1. So now I have my 2 factors. Take each factor, set it equal to 0. So I have 2 cosine x equals 0, cosine x plus 1 equals 0. If I divide both sides by 2, I still get 0. So we are looking for where is cosine of x equal to 0. So again, I'm picturing my lovely unit circle. Cosine is the x coordinate. So x is 0 at these top and bottom points. So we are looking for this in radians within that interval. So we have pi over 2 and 3 pi over 2. So x is equal to pi over 2. X is equal to 3 pi over 2 on this side. Here, solve this guy. Cosine of x equals -1. Again, another extraneous point on the unit circle. Not extraneous, what's the word I'm looking for? One that's sitting on the axes. Okay, so cosine of x equals -1 comes over here on this side, which is just pi, right? So we're looking for where does that equal pi? I mean, where does cosine of x equal -1? That happens at pi. Okay, so we currently have 3 answers. Now remember I told you we were going to have to check for extraneous solutions. Here's the key to remember with checking for extraneous solutions. This is true for anything. You need to check every single solution back into the original to make sure it works, okay? So that means we go back to the very original. So cosine of x plus 1 equals sine of x. And we will check this. So cosine pi over 2 we know is 0. 0 plus 1. Sine at pi over 2 is just 1, so we know 1 equals 1. So pi over 2 works. I have a different colored marker here to say, check, we checked it, it works. Okay, so then 3 pi over 2, let's try that. 3 pi over 2 plus 1 is equal to sine of 3 pi over 2. So cosine of 3 pi over 2, we already know is 0. So you get 0 plus 1. And then sine of 3 pi over 2, so think sine is your y. What is y here? Uh-oh. It's negative 1. So this is one of those instances where I was telling you squaring it does mess it up, because 1 squared is 1, negative 1 squared is also 1. So this one is going to mislead you. This term does not work. X equals 3 pi over 2 is not in the final solution set. The last solution that we're going to check is this pi. So we'll do cosine of pi plus 1 is equal to the sine of pi. So cosine of pi, that's over here, that is going to be negative 1 plus 1 is equal to sine of pi. So what is sine? That's your y coordinate, 0. So negative 1 plus 1, 0 equals 0. Yay and yay. So our two final solutions for this question are x equals pi over 2 and x equals pi.